Welcome to this lesson on inequalities. In this video we're going to learn what inequalities mean, how to solve them, how to represent the answers on a number line, and how to deal with the most important rule in the whole topic, when the sign changes direction. We'll also finish with graph style inequalities so that by the end you'll have the full GCSE picture. An inequality is similar to an equation, but instead of saying that two things are equal, we are comparing them. For example, 5 is greater than 3 and 2 is less than 7. So inequalities tell us that one quantity is bigger or smaller than the other. At GCSE there are 4 main inequality symbols that you need to know. Greater than, less than or equal to, and greater than or equal to. The ones with the extra line underneath include the boundary value itself. If we write x is greater than 4, that means that x can be any value bigger than 4. So 5 would work, 10 would work, 100 would work, anything greater than 4. But 4 itself does not work because the inequality says greater than, not greater than or equal to. To represent this on a number line, we put an open circle at 4 because 4 itself is not included, and then we put an arrow to the right because we want the numbers greater than 4. If the inequality is less than or equal to 3, then 3 is allowed, so on the number line we'll use a filled circle and put an arrow to the left. So to compare the two, if x is less than 2, we use an open circle at 2 and put an arrow to the left. If x is less than or equal to 2, then we put a filled circle and put an arrow to the left. Now let's solve an inequality. The good news is that this works exactly like equations. For x plus 5 greater than 7, we subtract 5 from both sides. So the answer is x is greater than 2, and on the number line this would be an open circle at 2 with an arrow to the right. Let's do another one. For 3x is less than 12, we divide both sides by 3. So x is less than 4. At this stage, inequalities are just like equations. But now we're going to reach the most important rule in the whole topic. Suppose we have negative 2x is less than 4. To solve this, we need to divide both sides by negative 2. But when we do that, the inequality sign must change direction. So here's the takeaway rule. When we divide by a negative number, we have to flip the inequality sign around. So the answer is that x is greater than negative 2. To visualise this on a number line, we have an open circle at -2 with an arrow going to the right. Now let's look at inequalities with brackets. The process is still the same, but we're just going to expand it first and then solve it. Expanding the bracket gives 2x minus 6 less than or equal to 8. Add 6 to both sides to get that 2x is less than or equal to 14. We can then divide it by 2, so x is less than or equal to 7. Now have a go yourself at drawing this on a number line. It should look something like this. The final part of the topic is graphical inequalities. These appear more often on higher tier papers, and the key idea is that instead of finding one number line answer, we are finding a whole region on a graph. If the inequality is y is greater than 2x plus 1, we first draw the boundary line y equals 2x plus 1. Because the inequality is strictly greater than, the line itself is not included, so we draw it as a dashed line. Now we shade the region above the line because y is greater than the values on the line. If the inequality includes equality, like y is less than x plus 3, then the boundary line is included. So this time we draw a solid line, and because y is less than, we shade below the line. That brings us to the end of this lesson on inequalities. If you have any further questions, leave them down in the comments below and I'll get back to you. Thanks, bye bye.